All right, I made the last two videos without a hat on, so you got to see my bald head. This time, wearing my University of Miami hat that I got for Christmas. That's where my oldest daughter goes to school. So anyway, go Hurricanes. All right, Mr. Davis did a great job on the last video explaining the eye. Really, there's nothing that I would add. It seemed like every time I think, oh, I'm going to give this as an example, Mr. Davis said it, so he's doing a great job. The only thing I would add is that lens that Mr. Davis was talking about getting a little harder, a little firmer as you get older. That's where his eye strain came in. That's like the lens on the camera. So if your lens gets harder, it's not going to be able to focus as well. So you're going to be out of focus. So all of the focusing happens right there. Okay, and then Mr. Davis mentioned I was going to be able to talk about rods and cones. And they're called rods and cones because they look like rods and cones. So notice this is a lot more like a cylinder, very cylindrical, and this is more tapered at the top, so it looks more like a cone. And these are on the back of your retina, so I'm actually going to back up. So you have rods and cones all over here. Well, actually, with one spot right here, but we'll talk about that in a minute. So rods and cones all on the back of your retina. Now, you notice the image is being projected right here. There are rods and cones up here too, and we're going to talk about that as well. But these are on the back of your eye, so light goes in, hits your rods and cones, and that's what gets excited and sends information back to your occipital lobe. So I'll move this up here. Here's basically, now there's really no reason for you to not remember which one sees color, because cones see color. They both start with C. So cones see color. So you'll notice here, what's interesting is, and rods see black and white. Now, there are a lot fewer cones than there are rods. There are a lot of rods, and I'm going to go back here. Let me see if I can go backwards here. It's not letting me. Pause for a second. All right, I found it. So most of the cones are right here. Almost all of your cones that see color are right here in your fovea. So that's where you're seeing almost all of your color. You have really precise vision in your fovea, which is where your cones are. So right there in your fovea, you see lots of cones. So right dead center in the back of your eye. Everywhere around there is mostly rods. And that's going to come up in a minute, so let's not overextend ourselves yet. So cones are in the center, in the fovea. Rods are in the periphery, on the outside. Your cones are not very good in low light. Cones in your fovea in the center. So that's why you have to turn on the light when you're reading. Your parents would come in and say, oh, you're getting eye strain because you're turning it on. So the cones are not good in low light. Your rods are very good in low light. Now here's an interesting thought, a couple of things about rods. When you go outside at night, it looks kind of silvery. The moonlight it's silvery, it's black and white. No, everything is still the same color. Why do you see everything as silvery? Why does it look black and white at night? Because your cones aren't working very well. Your rods are working really well. So your rods are seeing the black and white. So if you're out in the beautiful moonlight in the morning, it looks kind of black and white world because it's only your rods. Because your cones are not very good in low light, but your rods are. Here's another reason. Let's talk about the periphery. Now this is funny. I'm not a very good actor, but I'll do my best. If it's super dark and you're looking around for something, you'll do this. So like your hands. Now notice what I'm doing. And you've seen this before where you're looking. You're not looking at your hands. You're not going like this. You're going like this. Why? Because it's dark and you're trying to get your peripheral vision involved. So you're going like this because you're using the rods in your peripheral vision in order to try to see your hands. So if you're going around like this, it almost looks like you're blind when you're doing this. But what you're doing is you're using the rods, which see much better in low light. They're very sensitive in low light. Again, you see color really well in your fovea where the cones are, and you don't see color very well where your rods are. And cones are very detail sensitive. So, and one of the things that I would point out in class is your peripheral vision is terrible. It really is. Your brain is sort of making guesses. And when I say let's try the marker experiment, what I would do in class, and maybe we'll do it if we get back in class, where I would hold a marker up here and I'd put it out here in your peripheral vision. And so you wouldn't look at it, you'd be looking out here. And I'd say, guess what color it is? And you were terrible. You couldn't see color. You knew the marker was there. You could kind of see it, but you couldn't tell what color it was. Again, cones, color in the center of your vision. Very, very detailed, not very good in low light. and the rods are around the outside, much more of them, black and white, not very good in color, very good in low light. That's why you do this. And so once it hits the rods and cones in your retina, now look at this. Okay, just take 10 seconds and write this down super fast. JKLOL. Okay, here's what happens. So it comes back and it hits the back of your retina. And you're not going to need to remember this, but I'm going to give you a mnemonic because it kind of has been on the test, but not exactly like this. So you have the rods and cones right here. And they combine into the bipolar cells, and then the bipolar cells. And notice over here, then we have combos here to here, we have combos here to here, and then they all go together and go to your optic nerve, which seems weird. It just seems like it's a lot more complex than it needs to be. But it seems like a lot of things in our body were designed very simply, and as they got more complex, we just built complexity on the top of simplicity until we get something that looks like this. Here's all you need to remember. The only thing I've ever seen on the test. Which order does it go? So it goes your rods and cones in the back, then it goes bipolar, then it goes ganglion, and then it goes to the back. All you need to remember is they go in alphabetical order. It goes B and then G, and then they combine into your optic nerve. Okay, and you can see that this area right here. So all around the back of your eyeball, you have these. They combine to your ganglion cells, excuse me, bipolar cells, and then they go to your ganglion cells. And then all of them combine and they said all this information goes down to your optic nerve right here, which is going to come in handy in a minute. So your optic nerve again right here, so they all combine down here to go to your optic nerve, and your optic nerve goes back to your occipital lobe. So transduction is occurring in your rods and cones. What you're getting is electromagnetic waves hitting your rods and cones, and your rods and cones are converting that into a neural impulse. And then those neural impulses go to your bipolar, go to your ganglion, go to your optic nerve, and they start to go down. Now here's what's interesting. Once you get to your optic nerve, though, once they all combine into your optic nerve, you get a blind spot right there. There are no rods and cones on either part of your eye right there. And there's a in your book, you can test your blind spot. What you do, and it's all right there. So just go to your book and find it. And as you start looking at your peripheral, what'll happen is you'll notice something on your book disappear. And you'll go, holy crud, my whole life I've had a blind spot in both of my eyes and you've never noticed it because your brain fills in the gaps. So each one of us has a little blind spot right there in our peripheral vision where the optic nerve meets the eyeball and the retina. Okay, pretty crazy stuff. And then we do it in class, but again, it's in your book, so we don't need to do that again. We are good. I think this is the last thing I'm going to do. Now take 10 seconds and draw this in your notes super fast. JKLOL. Now here's the point that I wanted to make, and here's what we want to think about when it comes to the brain. Because we talked about the brain, how the right side of your brain controls the left side of your body, and the left side of your brain controls the right side of your body. So it would make sense that your left eye went to your right occipital lobe, and your right eye goes to your left occipital lobe. That would make sense, but that's not what happens. It's kind of crazy. So take a look right here. So, and I'm going to try to visualize this for you, and maybe you can kind of figure this out a little bit more later. But so notice let's look at the black lines right here. So let's say we presented something to the right side of my vision over here. So let's say these are my eyeballs protruding from my brain like this. And we present something to my right side. So I'm looking straight ahead, and we present something over here on my right side. What happens is the light travels into my eye, it travels in a straight line, and it hits the left side of my eyeball. See that? So something out here would travel in and hit the left side of this eyeball, and it would hit the left side of this eyeball. Okay? So any information on the right side hits the left side of my eyeball. Then we get the left side of the eyeball. Now notice again the black here. It goes here and it combines and goes to your thalamus. We've talked about the thalamus before. And so information from the left side of each eyeball combines and goes to the left side of your brain. So let's think about this. If you present it to my right side, if you present something right here, it hits the left side of each of my eyeballs, combines, goes back to my thalamus, and hits the left side of my brain. So what that says is a piece of information here hits the left side of my brain, and a piece of information here, which travels across, hits the purple lines, goes to the right side of my brain. So if I cover one eyeball, we are still going to get information traveling to both sides of my brain. Anything that's hitting the left side of my eyeball is going right here. Anything that's hitting the right side of my eyeball is going right here. So that is a very complicated thing right there. So it hits the retina, goes to the optic nerve, hits the visual area of the thalamus, and like almost every part of the brain, there's a left and a right on each side. It's a symmetrical brain, like almost everything. And then it hits the visual cortex, which is the outside of your occipital lobe, and then we have vision. Okay, that's pretty complicated. You might need to watch it again, but I'll let Mr. Davis take it away.